This is a quick review of multi-step phase change problems. So you'll recognize that this is a phase change graph. This would be the melting or freezing point, and if I'm talking about water, as it says in the title here, that temperature is 0 degrees C, and this temperature up here would be 100 degrees C. All right, so 0 C, 100 degrees C. We had the three formulas that we had in the previous quiz. Which one of those three applies during a temperature change? That would be here. So Q equals mCp delta T, Q equals mCp delta T, and Q equals mCp delta T. So that formula applies wherever there is a temperature change. You see temperature is increasing here. It's going from 0 to 100 here. It's an increase from 100 to wherever up there. It's an increase. So temperature change formula applies where there is a temperature change. Where melting or freezing is occurring, we use the Q equals mHF, and where boiling is occurring or condensing, mHV. So those are your formulas that you use. So if you, a couple of scenarios, suppose you had some ice down here. You all know that this, I guess, would be ice, and this would be liquid water, and this would be steam up here. So if I have some ice at that temperature, and I wanted to find how much energy it took to make the temperature of the water that was in the ice form warm up to liquid form, so we'd have to add up the energy changes. You'd have an energy calculation for this region, plus an energy calculation for this region, plus an energy calculation for that region. So you'd have 3 steps, and you would add them all together. Another scenario, if you had some water at this temperature and wanted to know how much energy it took to get it up to this temperature, you'd have to calculate how much energy it took to get to the boiling point, then how much energy it took to cross boiling or make it all boil away, and then how much energy it took to raise it to the final temperature. So you would end up with, again, with 3 steps. This energy plus that energy. So just a quick scenario, suppose we had some water at 50 degrees. Suppose it was, so there were 75 grams of the water, 75 grams, and we wanted to raise the temperature, go up to 125 degrees. All right, so we're going to go, we have 75 grams of water, it's at 50 degrees, we're going to go to 125. All right, so the way you would handle that, first step, Q is equal to, from 50 to 100 would be mCp delta T. So you would end up with a mass of 75. Specific heat capacity, I'm just going to use the calorie value that will be on the quiz. And then the change in temperature from 50 degrees to 100 degrees is a 50 degree change. So you'd end up with 75 times 50. And real quick, we'll calculate that. So 75 times 50, 3,750 calories. All right, the second step would be to cross the boiling point. So that would be this formula, Q is equal to mass times heat of vaporization. So you're looking at 75 grams times 540 calories per gram. Once again, the 540 is listed on the quiz, so it'll be 75 times 540, take 40,500 calories. Then the third step, we'd have to go from here up to here. So we would be looking at the change in temperature formula again, mCp delta T. The mass is still 75 grams. The specific heat capacity of of steam is 0.5 calories per gram degree C. And the change in temperature, now we're going from up to 125, but we are at 100 right here, so from 100 to 125 is a 25 degree change. So we end up with 75 times 0.5 times 25, 938 we'll call it, 938 calories. Now you're noticing all these units are canceling except for calories, and so on. All right, grams cancel. So now to find the total energy change, it is 3,750 plus 40,500 plus 938 if you add those together, 3750 plus 40,500 plus 938. Total energy change, 45,188. We'll just call it 45,200 calories. So that's how you do the multiple step problems.